Hi mentors, welcome to our tutorial video. Here we'll introduce you to the homepage, your profile, how to claim submissions, and finally how to lead students through each stage of the engineering design process. In the next training task, we'll dive a little bit deeper into how to give high quality feedback to students. But for now, let's get you better acquainted with the main features of Curiosity Machine. Landing on the homepage, you'll see a menu on the top left-hand corner. Here you can access our FAQ page, which lists commonly asked questions for mentors. You'll also be able to find our mentor page, which showcases all of the awesome members of our community. So let's go ahead and log in. Here you'll see and have access to your profile page. There are a few important areas of your profile, including the About Me, Expert In, and I'm Curious About sections. Having a fully completed profile, one that shares information not just about your work but also about your hobbies and interests, is key to connecting with students as a role model. Simply click Edit Profile to update your profile. Creating an intro video is actually a great way to share with students. So let's now explore how to claim and start mentoring a student submission. In the Unclaimed Student Challenges section, you'll find current projects in need of mentors just like you. At the end of this training, we'll actually ask you to sign up to mentor a particular program, one based on your location and interests. This way you can connect with your students in advance and be prepared when their submissions arrive. Clicking the icon takes you to the page to claim their project. Let's click Claim to start. Here we can see Victor is building an air-powered spinning machine. He's currently at the plan stage of his design. In order to better understand what he's building and what type of advice for you to provide as a mentor, there are two important sections: the inspiration stage and the guide. Let's check out the inspiration stage first. Every design challenge is based on the real work of a scientist or engineer. So before students start this air-powered spinning machine design, they're actually going to watch an inspiration video about Tony and his work as a Boeing aerospace engineer building the CST-100 space vehicle. Feel free to watch this video to learn more about the design challenge and how it connects to Tony's work. Let's next check out the guide. Here you'll find three main sections. How to make it shows the students an instructional video, which is an example of how to build a design. This is actually a very important part of your role as a mentor, because you want to encourage students to be creative and to build a design that is different or more advanced than this instructional video example. Learn More provides students with additional content information and visuals related to the design. And finally, there's the Mentor Guide, which is your tip sheet to help you provide high quality feedback for this particular design challenge. Here you'll find the challenge goal, top examples of feedback from other mentors, an overview of the science and engineering concepts involved in the design, images and text within these to use for your feedback. Quick tip, you can just click and drag these photos to your desktop and then drag them back into the window when providing photo feedback. You'll also see feedback advice based on common issues students run into. And lastly, a crowdsourced feedback sheet. This is where you can list the resources that you found online to provide good feedback for this challenge. All set with the guide section? Alright, let's go back to Victor's design. Since he's only at the plan stage, you're going to start by introducing yourself and writing any initial comments or suggestions for his design. After that, you're going to move to the build, to the test, to the redesign stage, and then finally to the reflect stage with Victor, going back and forth sharing ideas. Let's see how this process works by checking out an actual example of mentor-students interacting. In this submission, Katie is building a belt mechanism with the help of her mentor Amanda. You can see that Katie has posted her plan and her first version of what she built. Amanda starts by introducing herself and giving some preliminary ideas and suggestions on how to improve her design. Her key suggestion is what would happen if the holes were further apart? This is going to help Katie create an improved second version of the belt mechanism. And since Katie is building at school, as a part of her 9th grade Intro to Engineering class, she'll take a few days to return to the project. So all the interactions you have with students usually are asynchronous, you going, posting something, them coming back, and it'll last over the course of a week or maybe 2 weeks until you finish the final design. But right now, Amanda has asked, so Katie, what did you change? And Katie mentions that she measured the distance between the holes and made sure they were even. This second change, this iteration, has helped Katie successfully achieve the challenge goal. Now that Amanda's seen her redesign, and that she's actually built a successful version of the challenge, she's going to move her to the reflect stage. You can do this by clicking the Move to Reflect stage button. Now at the reflect stage, Katie is going to be able to answer the final reflection questions and also choose an image to share in the inspiration gallery. As a mentor, you want to make sure and click the Feature Image as Example button in order to share this final version. Once Katie has answered the reflection questions, Amanda is going to provide one last comment. Here she recaps what they learned together and a final idea for Katie to explore. So this example is a great back and forth interaction, and it goes through every stage of the engineering design process. In the next task, we'll take a little bit closer look at a few more mentor-student interactions together, and then we're going to be able to discover what makes really great feedback. Thanks for watching, and we'll see you soon on Curiosity Machine.